Hey guys, today I'm going to be bringing you a video on how to simplify the equation for calculating the equivalent resistance of resistors in parallel. So many people are only taught the initial equation for calculating the equivalent resistance in high school, but with this method, I'm going to show you how to greatly simplify equivalent resistance and will hopefully save you a bunch of time when you're doing your homework, tests, exams, etc. Okay, so let's get into this. So first thing we have here is our parallel circuit configuration. We have the variable resistances of R1 and R2. They can represent any possible value you have for resistances, and this method will work. So let me show you the actual equation that we will end up with. So here we have Req is equal to R1 times R2 over R1 plus R2. Now Req is equal to the equivalent resistance, and R1 is your first resistance, and then R2 is your second resistance. So I'm going to walk you through the proof of how I got this equation right here. Okay, so let's begin. First, we start off with the equation that we're all originally taught in high school. 1 over Req is equal to 1 over R1 plus 1 over R2. Okay, so through a series of algebraic manipulations to this equation, we can eventually end up with the equation. Okay, so let's start off with the first step, and that's going to be to find the common denominator between the terms 1 over R1 plus 1 over R2. So we can do this by multiplying the 1 over R1 term by R2 over R2, and then we can multiply the 1 over R2 term by R1 over R1. Okay, so we have that. Now we can simplify these two terms on the right by adding them together, and this will get us R1 plus R2 over R1 times R2. Okay, so from here, what we're going to do is cross multiply the terms Req and R1 plus R2, and then cross multiply 1 times R1 times R2. And this is going to get us this right here. So here we have Req times R1 plus R2, and then we have that equal to R1 times R2. So the final step in calculating for the equivalent resistance is dividing R1 plus R2 from both sides of the equation. Req is equal to R1 times R2 over R1 plus R2. And this is the same result we had in the start of the video, therefore completing this proof.